Okay. All right, we're back. Fortunately, perhaps saved for where that conversation was going.
So, it was a good conversation. We were right in the middle of something. We were on the verge of something.
How would you use the restroom then? The verge of
You don't want to know. Moving on.
You get like other there.
See, I knew this conversation was going to digress.
You don't have to like stick by the car.
Fertilize the field beside you.
Okay. You'll notice here, I drew a chart for triangle 1 and triangle 2. Okay, you know for sure, without doubt, there is one triangle. We got an answer. And we know in that triangle then that angle C is 64.3 degrees because we calculated it. Okay, what else do you know for sure in that triangle? About angles. Do you know any of the other angles in that?
56.
Yeah, we know angle A is 56. It was given to us from the start. So therefore, since I know those two are sure, could I find the third angle? Yeah, I could go calculate an angle B. My gosh. So if I actually subtracted those two angles from 180, that's 120.3, so that's going to be 59.7. We know, we got a triangle. Answer, for sure, one triangle exists. Guaranteed. Now here's the wrinkle. How do you know if there could have been a second triangle? Well, the whole second triangle aspect, you remember when I drew that triangle with the 8-inch line? I drew one side over this way, or I said one side could come over this way. So, and the angle that's changing is this one right here. It could be an acute angle, or it could be a big obtuse angle over here, because we know that when sine is a positive 0.911, don't we know that sine can be positive in two quadrants?
Oh, yeah.
So therefore, it could have been a 64.3 degree angle in the first quadrant and stayed 64.3, or it could have been 64.3 over here in the second quadrant. So it's possible you could, if you have a second triangle, angle C would have been what you get when you do 180 minus 64.3, which would be 115.7. So if there's a second angle C, it has to be from subtracting that from 180. Now, the key thing here is where people mess this up. You must do this with the angle you calculated. Because, like, we've calculated angle C, but say the problem had asked you to find angle B, I have people who want to do this with the angle they're trying to find. You have to do it with the angle you calculated. If you calculated angle C, that's the one you subtract from 180. Okay. We still know angle A is 56 degrees. That was given. That can't change. Okay. How you know whether your second triangle works or not is whether angle B, is there still room for angle B yet to exist in this triangle?
Yes.
If these two add up to under 180, and so that B could exist, you have a second triangle. If these two add up to more than 180, then there's no way the second triangle could have existed. Does that make sense? So in our case, yeah, if you add those together, we got what, 171.7. So that would leave us, what 8.3 degrees? So in this case, yes, both triangles are possible. And you would have two sets of answers. Woo! That was exciting? Okay.
Wait, why are we clapping?
So we are going to make a little list of how to check this. And now we're very rhythmic too. Okay. First of all, when's the only time you even have to worry about having two triangles? Side-side angle. If you don't start out with side-side angle, if you start out with angle-side angle or something else, this isn't even a concern. You only worry about this if it's side-side angle. Okay. So, your basic set of steps here. You're going to solve a normal law of sines to get your first answer. I'm going to call that angle A. Okay, what did I have to do to check for the second triangle then? I got the 64.3. What did I have to do to go check the second triangle?
What?
What did I have to do to check for the second triangle?
Minus 180.
I had to minus that angle I calculated. Angle A, in this case I calculated angle C. I had to subtract it from 180. So yes, then you're going to go, okay. Oh, I didn't label this. Usually when we talk about the second triangle, if this was angle C, they'll call this one C prime. A stayed the same both times, and they'll call that one B prime. When they want to talk about a second one, they put prime symbols on it. So in our case, if we want to find the second angle A prime, yes, you're going to do 180 minus A, and you're going to find that angle. And then, how did I check for how did I know whether this was going to work or not? If that angle, so if the new one you just calculated plus the given angle you started the problem with, okay, if that comes out to be less than 180, what do you know? Does the second triangle exist or not? If you add those, when we added 115.7 and 56, if it comes out less than 180, is your second triangle good or bad? Good. If it comes out less than 180, then the second triangle exists. If it comes out more than 180, the second triangle does not exist. You just have to do a few of them. Your Lao science problems today are pretty much all side-side angles, so that you have to check it.
Is that it?
You know, I suppose the law of cosine is pretty straightforward. But I don't know why that seemed like that took us a long time for no reason. Okay, law of cosines, which handles our other congruence theorems. It deals with lots and lots of sides. Okay, and definitely since we're running a little short on time here, I'm not going to go through the whole crazy proof of this formula, but basically they come up with this formula by doing this formula. Remember, find the distance between 2 points, x minus x squared plus y minus y squared, all in a big square root. That's where they come from. This. If you really want to see it, they do the whole gigantic page-and-a-half proof in your book. It's there. But it comes from setting up coordinates and then doing distance formulas. But to make a long story short, what law of cosine says, and I don't think you saw this one in geometry. I think in geometry you only do law signs. Okay. Law of cosines is a little more to know, but after you work with it a couple times, you'll see the total pattern. If you're doing law cosines, and I put a triangle up here, and since I said this worked for side angle side, suppose you had known these three things. You do side C, side B, angle A. You knew that side angle side. What law cosines is going to do is it's going to find you the third side. Because you'll notice, if you knew these three things, you could not do law of sines because you would not have a pair. There's no way you have a pair there. So you would have to, this is going to find you that third missing side. So when you're doing law of cosines, It's take your other two sides and square them. B squared plus C squared. Subtract, and you're going to be 2 times those same two sides. If you use B and C here, you're going to use B and C there. And then it's the cosine of the angle you know, which is opposite the side you're trying to find. So if you're trying to find side A over here on the left, you'll know angle A on the right. Now, I'm going to write out all 3 versions of this. If you know one, you know how to do it. So if I was going to solve for side B, what letters would be over here on the right side? Yeah, A squared and C squared would then be your 2 choices, because they're the other 2 sides. So that would be minus 2 times A and C, the same 2 sides you just used, cosine of which angle? B. Since you're finding side B, it'll be cosine of angle B. And same thing then if you were solving for C, you would have A squared and B squared here on the right side, minus 2A and B again, and then it would be cosine of C. So
All I expect you to know is one version of it, because once you know one, you can do it.
So let us work problem and find out that log cosines is pretty sweet, other than one tiny wrinkle. Let me draw you a picture here. And this time we knew angle C is 35 degrees, side A is 3.7, side B is 5.8. Okay, you're looking at a what? Angle, side, 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 side. What are we looking at here?
Side.
You're looking at a side angle side. Yeah. Okay, side angle side, you're going, it's log cosine. Okay, you are forced. Anytime it's side angle side, there's only one thing you can go find. And that would be the third side. So you'll always have to go find the other missing side once you start out with it. So we're going to have to solve for side C first. According to the formula, you really don't even have to look at the formula. What numbers are you going to have to be squaring here?
A squared.
Yeah, you got to be using the other 2 sides they gave you. So you got to be doing 3.7 squared and 5.8 squared. That's all you got. Minus 2 times 3.7, 5.8, and cosine of, and once again, what's the only angle you got? 35. So it pretty, I mean, you can only use the 3 things they gave you, so it's pretty obvious what you got to fill in.
It'll put it on the calculator, right?
Yeah, and your calculator actually, it knows order of operations. You can plug this in exactly as you see it. Just plug the whole thing in at once. It'll crunch the whole number. So you'll end up with something like C squared equals 12.17. But then what do you have to do after that? Is that C squared? You'll have to square root it to actually get C. So that is easy to forget to do, is just to square root it at the end. And side C is 3.5. And if I had only asked you for that side, you would be done. That's how easy log cosines is. Okay, but what if I said, hey dude, I want you to now find me,
You should use the log sign
I gotta remember, yeah.
to find the angle.
Oh, boogers, okay. Well, we're going to find angle B.